8.6 is solving radical equations, which you have done before. You just haven't done it with higher powers than 2 or higher roots than 2. Okay, so before we get started, we do have extraneous solutions in situations like this. Just like when we had rational equations, right? It was numbers that couldn't make your denominator 0. Well, here with extraneous solutions, it's when you check your answer in the original equations and both sides don't end up equaling the same thing. Okay, essentially a shortcut of identifying this is when you isolate your radical with an even index. Okay, I can't stress even enough because that's the only thing that has a domain issue, right? We can't have negatives inside of an even index. So if you isolate your radical and you have an even index or an even root and it's equal to a negative number, there is no solution because we are only talking about principal square roots, and principal square roots are positive numbers. Okay, so our principal square root cannot equal negative. So when that happens, you can literally stop right away and say no solution. Okay, so I wrote out the steps for you. You obviously could keep those in your notes, but I'm just gonna go walk through these through you. So in number 1, I have one of my radicals isolated. I mean, it's my only radical. And once you do that, I said in step 2, raise both sides to the root power. What that means is whatever root this is, so obviously this is 2, I'm going to raise it to that power. And what I do to one side, I have to do to the other. Okay, so that is x, right? Because the square root of x times the square root of x is just x. Right? If you raise a radical to the same power, it's just going to cancel out that radical and you're going to be left with what's inside. It doesn't matter what power it is. So if this was like the fifth root, and I raised it to the 5th power, that would make the radical go away. Okay, so x equals 81. And then sometimes, I mean, you could do a mental check with these, but some of them you really have to check because you'll end up not getting the same thing on both sides. So the square root of 81 equals 9. We're only taking the principal root, so the positive root, so 9 equals 9. Great, that's my final answer. Okay, no issues there. So with number 2, I don't want you to think, oh my god, my radical's isolated, it's equal to a negative number, no solution, because you have to look at your root. Okay, my index is an odd number, and it's okay to have a negative number when it's an odd index. Okay, so I'm going to go ahead and raise this to the 3rd power because it's the 3rd root. Okay, so that's going to cancel out this radical right here, and you're going to be left with y equals negative 8, right? Negative 2 times negative 2 times negative 2 is going to be negative 8. And then we just need to check. Again, I don't care if you do a mental check, but you do need to check every time in the original equation. Negative 8. So the cube root of negative 8 we know is negative 2. Great, we're done. This is my final answer. Okay, with number 3, this one I can actually go ahead and say no solution. I have an isolated radical, right? I have a square root on one side of the equal sign with nothing on the outside of it. It's all by itself. I'm ready to solve. I'm going to square it. And I get, let's jump down here, x equals 64. Now if I check it, I get the square root of 64 equals negative 8. Well, again, we're only taking the principal root, so 8 equals negative 8. That doesn't work. Okay, so this would not be a solution, so I do not have a solution. So like I said, you could kind of use that trick and say, oh, well, my even radical that's isolated is equal to a negative number, so I could go ahead and say no solution right away. Okay, either way works. I like shortcuts, so I would use the shortcut rather than having to go through and check. Okay, so with number 4, my radical is isolated, nothing on the outside of the radical. Okay, that's what I'm looking for when I say isolated. It's the square root, so I got to square both sides. So I'm left with everything that's inside of the radical, okay? So I get x minus 7 equals 64. I'm going to add 7 to both sides because now I have to solve for x. So x equals 71. Okay, then we could do a written check or a mental check in the original equation. So 71 minus 7, does that equal 8? Well, I get the square root of 64, and principal root is 8, so they both equal the same thing, so I know x does equal 71. Okay. Number 5. So number 5, I do not have the radical isolated. That's what I mean by make sure that it's isolated. I have this outside of the radical. Okay, anything outside of this thing right here needs to go away. Okay, it's just like getting a variable by itself. So what I'm going to do is subtract both sides by 5. So I get the cubed root of x minus 3 equals negative 1. Now don't say no solution. I have an odd index, so that is okay. All right, so now I'm going to raise this to the third power because it's the third root. Okay, the radical goes away and you're left with everything that's on the inside. So that x minus 3 and then equals negative 1, right? Negative 1 times negative 1 times negative 1. Get x by itself. And so I get x is equal to 2. Okay, let's do our mental check, right? Plug it in right here. So 2 minus 3, that's negative 1. The cubed root of negative 1 is negative 1, so 2 does work. Now again, you could do the mental check or you could do the written check, but you have to check. Okay, I know it's annoying, but it's got to be done. Okay, number 6. So I see a plus 20 outside of the radical and I see a 2. Those both need to go before I even start squaring anything. I can't emphasize this enough. Before you start squaring things, those have to go. Okay, so I'm going to subtract both sides by 20. So I get 2 square root of 2x plus 1 equals negative 6. Okay, divide by 2, right? Because it's attached by multiplication. The opposite of multiplication is division. So I'm going to divide both sides by 2. I had 2x plus 1 equals negative 3. Well, I have an isolated radical that equals a negative number, even root, no solution. I'm going to stop myself right there. Done. Okay, and you wouldn't know this if you didn't isolate your radical. So always make sure you isolate your radical first. Okay, number 7. Same process. So yes, there's radicals on both sides, but they're both isolated, right? All I need technically is one radical to be isolated on one side of the equal sign. Well, here I have 2. That's totally fine. I'm still going to square both sides because it's the square root. Okay, that's going to cancel out the square root on both sides. And then I'm left with this super simple equation to solve. So I'm going to get x by itself. Subtract x, I'm going to add 1. So I get 5x equals 3. So x equals 3/5. Okay, make sure you check. I don't care if you hate fractions, okay? So plug it in. So 6 times 3/5 minus 1. 3/5 plus 2. Let's see if we get the same thing. So I get 18/5 minus 1, which is 18/5 minus 5/5, so that's 13/5. And then I get 3/5 plus 2. 2 also could be 10/5, so I get 3/5 plus 10/5, that's also 13/5. Great, it works. That's my final answer. Okay, number 8. So at least one side is isolated, which is great. And now I got to raise it to the third power this time because it's the cubed root. So I get 5x minus 2 equals 3x plus 2. I'm going to subtract both sides by 2. Oops, sorry, it should be 3x. Add 2 to the other side. So I get 2x equals 4, so x equals 2. This one's a little bit easier to do a mental check, right? 5 times 2, that's 10. 10 minus 2, that's 8. And then I get 3 times 2 is 6. 6 plus 2 is 8. So on both sides, I'm going to get the cubed root of 8. So this one checks out as well. Okay, number 9. So this is when it starts to get super fun. Just kidding, you're going to hate it, but you're going to be fine. So my radical's isolated. Okay, so we Gucci. I'm going to go ahead and square both sides. But guess what happens when you square the left side? You are going to have to FOIL, right? This is actually saying x plus 2 times x plus 2 equals 5x plus 16. Now, if you remember the trick, you could do the trick, right? Or you could FOIL it out and have the time of your life. So I'm just going to do the trick. You could go ahead and take the time to FOIL this out right now. But remember, the trick is when I square the first, that's x squared. Multiply these two together, and then multiply that by 2, so that's 4x. And then you square the last, so plus 4. Okay, equals 5x plus 16. And now guess how you have to solve this, right? I have an x squared right here that is not going to go away, so I have to solve by factoring. Remember, when you solve by factoring, you have to set everything equal to 0. So I'm going to bring over this 5x, and I got to bring over the 16. So these are going to go away. I get x squared minus x minus 12 equals 0. Okay, now that it's set equal to 0, I'm going to go ahead and factor. I get x minus 4, x plus 3 equals 0. Set both equal to 0. So my two answers are x equals 4 and x equals negative 3. Yes, you have to check two answers. Okay, so plug in 4. 4 plus 2, that's 6. So we'll plug in 4 right here. 5 times 4, that's 20. Plus 16, that's 36. The square root of 36 is 6, so 4 works. Okay, let's try the negative 3. I'm actually going to write this one out. Negative 3 plus 2 equals 5 times negative 3 plus 16. Oop. So negative 3 plus 2 is negative 1. I hope you could kind of see where this is going. I get negative 15 plus 16 equals the square root of 1. We take the principal root. These do not equal the same thing. Okay, so this cannot be a solution. And the way you could kind of check right away without having to go through all this work is when you have your isolated radical and you plug in your variable here, negative 3 plus 2, that's going to give me a negative number, and it's going to tell me that my isolated radical equals a negative number. So right away, I know negative 3 is not going to work. Okay, I hope that makes sense. Again, plug it into where your radical's isolated, where that arrow is pointing at the x. And if you get a positive number, it should work out. Okay, if you get a negative number, you have a radical equal to a negative, which we can't have, so that solution's not going to work. So my only answer is this x equals 4. Okay, number 10 is a doozy. Oops, sorry. So we need to get this lovely guy all by himself. Okay, so what I need to do is get rid of this 6x first. I see a like term that 6x can combine with. So 3 root x plus 1 equals 9x plus 3. Now that 3 is attached to the radical by multiplication, so the opposite of that would be to divide every single thing by 3, okay? So I get radical x plus 1 equals 3x plus 1. Now, I'm going to square both sides now that that guy's all by himself. And I get x plus 1, and yep, you got to FOIL this out. Okay, so this is either 3x plus 1 twice, or you could do the trick. Tricks always save you some time. Okay, so square the first, that's 9x squared. multiply these together, multiply by 2, so plus 6x, square the last one, so plus 1. Okay, do not bring this one over to the left side because my lead coefficient cannot be negative when I solve by factoring. Okay, so I'm going to bring everything over to the right side so I have a positive lead coefficient. Again, I know I have to solve by factoring because I have a variable squared that is not going to go away. Okay, so that means everything's got to be set equal to 0. So I get 9x squared plus 5x, and then those ones cancel out. Okay, so remember to factor things like this. You guys always forget how to factor these, but there's a GCF, right? The GCF is just x. So I get 9x plus 5 left in the parentheses. So my first solution is going to be x equals 0. And then 9x plus 5 equals 0. So x equals negative 5 over 9. Now I'm going to kind of use the shortcut and cheat a little bit. And I know when I plug in 0 up here, right, I'm going to get a positive number. Well, let's check the 5/9. So 3 times negative 5/9 plus 1, negative 15/9 plus 9 over 9. So I get negative 6/9. Now see, I'm ending up getting a negative number on that side of the equation, right? So that means I have a radical equal to negative 6 over 9. Can't have it equal to a negative. This one is not going to work. Now, it's not just because the negative 5/9 is negative, okay? When you plug it in, sometimes you'll get a positive number equal to your radical, and that's totally going to work out, okay? It's only when you plug it in up here, okay, and that ends up being a negative. Okay, you could very well plug in the negative 5/9, add it to something bigger than negative 15 over 9, and end up getting a positive number, and negative 5/9 would be a solution. Again, it's only when you plug it in, add those together, ends up being a negative, your radical equals a negative number, does not work. Okay, so I know that my solution is only x equals 0. Whew, okay, sorry, I know these are long, almost done. 4 more examples, and then we're good. Okay, need to isolate this radical, so I'm going to subtract both sides by 5. So 4, 3x plus 4 equals 2. Okay, now that it's a fourth root, guess what I have to raise it to? The fourth power. Okay, so that becomes 3x plus 4 equals 16. So x equals 4. Now this is not going to give me any issues because my radical is never going to end up equaling a negative number, so I know right away that when I check, it's going to work out. Okay, that's a little shortcut you could use when you're checking your answer, or you could just keep plugging in for x, calculating it out, seeing if both sides equal the same thing, but you should be good. Okay, number 12. Now we have this really long square root that we got to get by itself. Okay, so I'm going to subtract the 3x. And I get the square root of 5x squared plus 6x minus 7 equals 2x plus 1. Okay, now that it's isolated, I'm going to square both sides. Yay, more foiling. So 5x squared plus 6x minus 7. So radical goes away, just left with what's inside. I'm going to use the shortcut, or you could take the time to write it twice and FOIL it out. Okay, so I get 4x squared plus 4x, right? 2 times 1 is 2 times 2, that's 4, and then plus 1. Yay, solving by factoring. So I'm going to bring over this 4x squared, right? So I'm going to set everything equal to 0. And we get x squared plus 2x minus 8 equals 0. So I get x plus 4, x minus 2 equals 0, x equals negative 4, x equals 2. Okay, now let's check. Hopefully you could see when I plug in this negative 4 up here, what's going to happen. Right, I get negative 4 times 2, that's negative 8, plus 1, that's negative 7. I know that one is not going to work. Okay, can't have that equal to a negative. But if I plug in 2 up here, right, plug in 2 instead. 2 times 2, that's 4, plus 1, that's 5. That gives me a positive number equal to my radical. So 2 is the only one that's going to work. Okay? Again, you could plug it into the whole thing and, you know, take a little bit more time to figure out your answer. But hopefully you start picking up on these shortcuts. Save yourself as much time as possible. Okay? And then number 13 and 14, you are going to love these. So I already have a radical isolated. It's okay that this radical is not by itself. Okay? All I need is 1 that's by itself on one side. Okay? So what I'm going to do is square both sides. This becomes x plus 21. And this is still root x plus 3 times root x plus 3. Now you're going to have to FOIL that out. Okay? I'm going to use the shortcut because I'm a math teacher and I can. And I feel like if you tried it, you could do it too, right? So I'm going to square this first one. Square root of x times the square root of x is x. Then you multiply these two together, that's 3 root x, but then you got to multiply that by 2. So that becomes 6 root x, and then you square the last one, so that's plus 9. Now if you FOILed all this out, you would get the same exact thing as me, just a little bit longer, okay? So notice, I still have this annoying guy right here. Guess what that means? I have to do this all over again. So I need to isolate this. I need to get this by itself, nothing on the outside of it. Get rid of it, move it all to the other side. Okay, so what I'm going to do is I got to get rid of this x, right? So I'm going to subtract x from both sides, and I got to get rid of this 9. So I'm going to subtract 9 from both sides. So that becomes 2, 6 root x. Well, I still have that 6. Okay, think about how you could get rid of that 6 that's attached by multiplication. So I'm going to divide both sides by 6. So I get 1/3 equals root x. Well, now that that is isolated, I can square both sides again. So square this, square that. I get 1/9 is equal to x. Okay, if we plug this in up at the top, I know it's not going to equal a negative. I'm good. That's my final answer. Okay, so with these ones, you actually have to square twice. So, sorry in advance. So number 14, last one. I promise. Okay, so this one's already isolated, so I'm going to square both sides. So I get 2x plus 1 equals, let me just do the long FOIL way for you people who don't like to learn my shortcuts. Okay, so square root of x times the square root of x, that's square root of x squared, so I'm going extra long way, right? Then I get plus x plus root x plus 1. Okay, keep simplifying. 2x plus 1 equals x, because the square root of x squared is just x. These are like radicals, right? So that becomes 2 root x plus 1. Okay, we got to get that radical by itself. Do it all over again. Subtract x, subtract 1. So I get x equals 2 root x. Okay, still not isolated. Got to get rid of that 2 first. So I get x root over 2 equals the square root of x. All right, now we get to square both sides. So I get x squared over 4 equals x. Guess how you have to solve this? By factoring. Okay, what I'm going to do first is get rid of that 4. So I'm going to multiply both sides by 4. So I get 4x squared equals 4x. I'm going to subtract both sides by 4x. So 4x squared minus 4x equals 0. Okay, remember when you just have two terms, let's look for a GCF. So 4x I could factor out, and I get x minus 1. So my first answer is x equals 0. My second one is x equals positive 1. Okay, which will work out in both. Okay, and those are your final two answers. I know those ones suck. I promise you won't have a ton to do. If you get confused, please rewatch, pause, rewind, anything. Okay, I know this moves a little bit fast, but I did that knowing that you can pause literally whenever you want and go back and re-listen to what I said. Again, feel free to send me questions in the discussions or send me an email, and then we could talk further about any questions that you have. Okay, in the last video, my bad, I realized I made one tiny little mistake. When I multiplied both sides by 4, I made that 4x squared. So obviously these 4's cancel out, and I get x squared equals 4x. Okay, then I'm going to subtract both sides by 4x. Again, solve by factoring because I have an x squared left. We got our GCF, so factor out that x. So I get x minus 4 equals 0. So x equals 0 and x equals 4. Let's make sure that works. I'm kind of doing a mental check right now. And they both do. Okay, so these are actually the final two answers. If you caught that while you were looking at this, thank you. My bad. This is the right answer.